Have you ever wondered how computers perform repetitive tasks efficiently? The secret lies in a fundamental concept in programming called loops. Loops are the control structures in programming that allow a block of code to be executed repeatedly. They're an essential part of programming, making it possible to automate repetitive tasks and iterate over collections of data in an efficient manner. Whether it's scrolling through your social media feed, a slideshow of images, or a recurring update in a software application, loops are at work behind the scenes. They come in different flavors, including for loops, while loops, and do-while loops. Each type of loop has its unique use case, offering different ways to control how many times the loop should iterate, and under what conditions. Loops are the unsung heroes of the programming world, making our digital lives run smoothly and efficiently. Loops come in different types, each with its unique use case. Let's delve into them. First on the list is the for loop, used when the number of iterations is known in advance. The for loop is a powerhouse in the world of programming, designed to automate repetitive tasks efficiently. Its structure is simple yet effective, composed of three distinct parts: initialization, condition, and increment or decrement. Let's break them down. Initialization is where you set the starting point for the loop counter. It's essentially the kickoff for the loop. Next up is the condition. This is the rule that determines how long your loop keeps going. If the condition is true, the loop continues. If it's false, the loop ends. The final piece of the puzzle is the increment or decrement part. This is where you specify how the loop counter should change after each iteration. Now let's put this all into practice with an example using Python. Imagine we want to print numbers from 1 to 5. We can do this with a for loop like this. For I in range 1, 6, print I. Here, I is our loop counter, initialized at 1. The condition is I in range 1, 6, which means the loop will continue as long as I is in the range from 1 to 6. And the increment, that happens automatically with the range function in Python, increasing I by 1 after each loop. When we run this code, it prints the numbers 1 through 5, each on a new line. With just a few lines of code, we've created a loop that does the repetitive task for us. For loops are not just limited to numbers. They can be used with any iterable objects, such as lists or strings, making them incredibly versatile in handling various tasks in programming. Remember, the power of a for loop comes from its ability to repeat a block of code a known number of times. It's like having a personal assistant who doesn't mind doing the same task over and over again. That's the for loop, a powerful tool for handling tasks with known iterations. Moving on, we have the while loop, which comes into play when the number of iterations is undefined. This type of loop is a crucial tool in a programmer's arsenal, serving as a go-to when the precise number of iterations cannot be predetermined. So, how does a while loop work? It's quite simple, really. A while loop will keep executing the block of code within it as long as a specified condition remains true. The moment this condition becomes false, the loop breaks, and the program continues with the next line of code. Let's illustrate this with an example in Python, where we'll print the numbers 1 through 5 using a while loop. First, we initialize a variable, num, to 1. Then, we set up our while loop with the condition num less than or equal to 5. Inside the loop, we print the value of num, and then increment it by 1. Here's how that looks in Python. When we run this code, it will print the numbers 1 through 5. The loop starts with num at 1, checks if num is less than or equal to 5, and since it is, it executes the print statement and increments num by 1. This process repeats until num is no longer less than or equal to 5, at which point the loop breaks. A key point to remember with while loops is to ensure that the condition will eventually become false. If not, you'll have an infinite loop on your hands, and nobody wants that. So always double-check your conditions and your increment or decrement statements. While loops, therefore, offer great flexibility when the number of iterations is unknown. They are a valuable tool, facilitating a broad array of tasks, from simple counting routines to complex data processing operations. So, embrace the power and versatility of while loops, and let them do the heavy lifting in your code. Some programming languages offer a third type of loop, the do-while loop. However, Python isn't one of them. This intriguing loop is unique. Unlike the for and while loops that check the condition before executing the code block, the do-while loop executes the code block first and then checks the condition. This ensures that the loop's code block is executed at least once, regardless of whether the condition is true or false. In languages like C and Java, A do-while loop might look something like this. Do while condition. But don't fret because Python isn't left out in the cold. While it doesn't have a built-in do-while loop, creative programmers have found ways to construct similar functionality using the while loop. Now let's shift gears and talk about loop control statements. These are the secret sauce that gives programmers greater control over their loops. They include the break, continue, and pass statements. The break statement is a loop's emergency exit. It terminates the loop prematurely, and the control shifts to the statement immediately following the loop. For instance, if we're searching for a specific element in a list, once we find it, we can break the loop, saving time and computational resources. The continue statement, on the other hand, is like a fast-forward button. It skips the rest of the code inside the loop for the current iteration and continues with the next one. This can be useful when we want to avoid certain values in our loop counter. Finally, we have the pass statement. It's a bit of an oddball. It does nothing and is often used when syntactically a statement is required but no action is desired. Think of it like a placeholder, keeping the place warm for future code. Here's a fun fact. Did you know that you can use these control statements in both for and while loops? That's right, they're not picky and will work wherever you need them. So there you have it. The do-while loop, which executes its code block before checking its condition, and the 3 loop control statements: break, continue, and pass. Each one a powerful tool to add to your programming utility belt. These control statements provide programmers with greater control over their loops, enhancing their utility. A loop that never ends? Yes, they exist and are called infinite loops. Now imagine a piece of code running forever, never stopping. That's an infinite loop for you. They occur when the terminating condition for the loop is never met. While infinite loops might sound like an endless nightmare, they are actually useful in some cases. However, more often than not, an infinite loop is a programming error that you'd want to avoid. Let's consider a classic example in Python. In this case, the condition for the while loop is always true, which means the loop will keep executing indefinitely. Unless manually terminated, it will continue to print "this is an infinite loop" till the end of time. Now, let's shift gears and delve into some key concepts associated with loops. First up, we have loop control variables. These are the variables that control the loop's operation. For instance, in a for loop, the loop counter is a loop control variable. In a while loop, the condition for the loop to continue is a loop control variable. Next up is iteration. Each cycle of the loop, where the loop's body is executed, is known as an iteration. So, if a loop runs 5 times, we say it has iterated 5 times. Nested loops are another interesting concept. As the name suggests, these are loops within loops. They can be used to perform more complex operations, such as iterating over multi-dimensional arrays. Last but not least, we have loop efficiency. When dealing with large data sets, the efficiency of loops becomes crucial. An inefficient loop can significantly slow down your program, leading to longer execution times. So, it's essential to write loops that are as efficient as possible. In conclusion, loops are a powerful tool in any programmer's arsenal. They allow us to automate repetitive tasks and iterate over collections of data. But with great power comes great responsibility. It's crucial to understand how loops work and how to control them to avoid pitfalls like infinite loops. Understanding these key concepts enhances the power of loops, contributing to efficient and readable code.